Number 1, state the frequency and period of the following sinusoidal functions. So in this lesson, we talked about the frequency and period as the frequency being the b value in y equals sine or cosine of bx. The b value there is the frequency. And that tells me how many times it happens in 2 pi. How many curves do I see when I look from 0 to 2 pi? Whereas the period is how long is one cycle? How long does it take to complete one cycle? And we said these two quantities, the frequency and the period, frequency times period always gives us 2 pi. So we can use that relationship there to find the other given one of them. So state the frequency and period of the following sinusoidal functions. So clearly my frequency here is 8. So to find the period, I'm going to say 8 times the period gives me 2 pi. When I divide by 8, I get p equals pi over 4. So the period here is pi over 4. It takes pi over 4 units to complete one full curve. This cosine curve ends here, now at pi over 4, not 2 pi. One cycle ends at pi over 4, no longer 2 pi, because I put that 8 there. My frequency here is 2 pi over 7. That's the number in front of x. So to get my period, I'm going to say b times p equals 2 pi times 7 times 7. 2 pi p equals 14 pi. Dividing by 2 pi to get p by itself, I get p equals 7. It takes 7 to get through one full cycle of that cosine curve. So on the x-axis, after one cycle, I'm going to mark a 7. And finally, the last one here, my frequency appears to be 4/3. That's the number in front of x here. So 4/3 times the period, give me 2 pi. Multiplying by 3, I get 4p equals 6 pi. Dividing by 4, the period I get is 3 pi over 2. It takes 3 pi over 2 units to get through one full cycle of this sine curve. So knowing that relationship, BP equals 2 pi, is the huge idea of this lesson, and we're going to use when we start modeling with trig functions. A sine curve has a period of 2 pi over 7. What's the frequency? So this time I'm giving you the period. I want to know the frequency, so b times the period gives me the frequency. Sorry, BP equals 2 pi. The frequency times the period always equals 2 pi. I'm going to times 7. B2 pi equals 14 pi. Dividing by 2 pi, I get b equals 7. B has to equal 7 for that to be a true statement. So the frequency would be 7. It would be like sine of 7x. If I have that there, it has a period of 2 pi over 7. We see the frequency in the equation. We see the period on the graph. A child is on a swing. It takes the child 2 minutes to swing back and forth 30 times. So if I was to make a curve here, here's 0, here's 2 minutes, I would get 30 cycles of this sinusoidal curve here. I'm actually going to make it a sinusoidal curve. We're going to pretend like there's 30 of them. We're going to pretend there's 30 of them in that 2 minutes. I want to know what the period and frequency would be for this function. So what is one cycle here? How long does it take me to do one cycle here? Well, there's 2 minutes it takes me, I can do 30 of them. So one of them, well, 2 out of 30. The whole is 2. I'm breaking it into 30 parts. I have a whole 2 units here that I'm splitting into 30 parts. So the period is 1/15th minute. 1/15th is the period. It takes 1/15th to get through one cycle. So to get the frequency, I'm going to say BP equals 2 pi. So my B value, when I multiply by 15, would be 30 pi. That's the frequency. Period is 1/15th. Because if I take 1/15th and have 30 of them, that would get me all the way to 2. Write the equation of a sine function. So y equals the sine of x such that it has an amplitude of 2. The amplitude's the coefficient. A period of pi over 2. We don't see the period in the equation. The frequency goes there. And a midline of y equals -3. Those are the easy parts. To get the b value, to get the frequency, that's what goes here. I'm going to say bp equals 2 pi. Well, if I times 2, b pi equals 4 pi. So therefore, b has to equal 4. 4 is the number that goes in front of x. So that's my function there, 2 sine of 4x minus 3. That's a sine curve with that given information. You could have stuck a -2 in front of there instead, because the amplitude, if I see a -2 out front, the amplitude is still 2. But that's okay. We can say it happens or it doesn't. We'll move on. Sketch one cycle of the function from above. So 2 sine of 4x minus 3. So we always start with our midline. I have a midline of y equals -3. That's my midline. And since my amplitude is 2, from there I'm going to go up 2 and down 2 from the midlines to get my max and my min. Now we already know the period is pi over 2 from the previous question. So I'm graphing a sine curve. Sine curves are little hill, little valley. So when I go to graph this here, I'm going to start at, sine starts at the midline, max, midline, min, midline. There's one cycle of this sine curve. However, we have to label on the x-axis, where does it end? Where does that one cycle end? Well, we said it has a period of pi over 2. So that's the period there. Don't forget to mark all of these things here. You have to mark the midline, the max, the min, and where one cycle ends, because it asked me to sketch one cycle.